Recording. All right. Hello, everyone. This is Joe Fairley from Ascent Fabrication. You are listening to the Fabrication Friday podcast, where we talk with industry-leading experts in the 3D printing industry and associative industries for the health sector, other sectors for 3D printing applications. There are so many different applications that we can get into. We're here talking today with Sebastian Schmidt from PPprint. PPprint is a German company looking to push the boundaries of polypropylene-specific 3D printing. So we're here today talking with Sebastian about kind of his journey into the 3D printing industry, as well as their specific polypropylene filaments. So Sebastian, would you like to introduce yourself and tell us a little bit about PPprint?
Sure. Yeah. Thank you very much, Joe, also for the invitation. My name is Sebastian, and I am co-founder and currently product manager at PPprint, German-based company in the south of Germany, Bavaria. Basically, our focus is, as you already said, establishing polypropylene in the 3D printing market, especially the extrusion-based 3D printing market, and bringing this material that is used in several applications in so many industries already with different production processes, like, for example, injection molding, and use this great property profile that polypropylene offers to bring it also to the field of 3D printing and offer customers from these 3D printing industry the benefits that polypropylene can offer.
Right. So polypropylene is kind of a long time industry standard material, right? So why polypropylene and why 3D printing filament?
Well, polypropylene is one of the most used plastics in the world currently, and this is due to the fact that it has a broad property profile. So it's not only one advantage that makes it interesting for this industry or that industry. It's basically the broad property profile coming from mechanical properties, but also I would say chemical properties that make it very interesting for various different applications. So maybe talking about mechanical properties, it is a very lightweight material because of the low density, and at the same time it's very break resistant and also semi-flexible. So it enables a lot of applications, like, for example, in the medical technology field for 3D printing, for the booming field of 3D printing, orthotic or prosthetic devices. But also it has very great properties regarding the chemical resistance. So PP has no problem to be in contact with waters, alcohols, acids, bases, and therefore often used application is to produce, for example, tanks even. But also this makes it interesting for a lot of other applications where there will be maybe the contact of any other substance. So this makes it more from the side of the chemical resistance. Other benefits would be to mention, very important, it's very good recyclability. PPprint can be 100% recyclable, or is 100% recyclable, and can be used in therefore several times. And the key aspect about this, because PP is already a very, very broad used material in the world, the recycling streams are established very, very good. So it is not only theoretical possible to recycle polypropylene very good, it is also practical possible because the recycling stream exists. Why we're doing this as a filament is, as I said, bring this advantage and this property profile to the 3D printing market. And the idea of PPprint, maybe coming to this, is based on the fact that around about 10 years ago, there were already quite good, let's say, FDM printers on the market, but there was a lack of high quality materials. And there was a doctoral thesis at the University of Bayreuth that basically had answered the question, how can you bring polypropylene through the field of 3D printing? And the results of this doctoral thesis were so groundbreaking, better than everything that was on the market at this time, that a spin-off, the PPprint in the end, developed. And more than 5 years ago, PPprint was founded then, starting really with a small product portfolio, I would say, just
Sure.
the filament and maybe the base plate that we'll maybe also talk about, that we patented to start. Now, over the last 5 years, a lot happened. Different colors, different spool sizes, different cooperations with several printer manufacturers came out of this. And yeah, so I think the goal is to establish this great material for several applications in the field of 3D printing.
Right, right. Yeah, and we not to mention that we have a great partnership that is definitely growing at this point through Ascent Fabrication and PPprint. I got in touch with Sebastian here. What is it? Probably almost a year ago now. Trying to look around for more durable 3D printing materials for the prosthetics and orthotics industry. You know, working as a certified prosthetist in the field and having this 3D printing knowledge through Ascent Fabrication, you know, we were looking to try to bring more durable devices to the patients that could use FDM printed devices in a patient end use manner, right? You know, something that someone's going to walk out of your office with for a long period of time. So I'm happy to say that now we have some patients out on some prosthetic sockets and lower extremity orthotic devices, AFOs, for more than 10 months now, out in the wild and being very active with those devices. So I can attest to the structural durability of the PPprint PolyPro. You know, being a user of it myself, printing with a various number of the colors and on different printers. I have noticed that it prints quite well, you know, and always there's the little bit of shrinkage that occurs and warpage that occurs that we've managed to really minimize as much as possible in order to achieve some really nice prints. So, you know, I'm really keen on trying to find more use cases for that. You know, we're starting to get a little bit into some pellet printing as well. And so I have another question there for you. With PPprint starting out in the polypropylene sector, did you start out with pellets, or did you kind of go first to filament printing, or did it simultaneously, you know, develop at the same time?
Yeah, so in general, of course, the main nature that you buy polypropylene in is normally granular, so pellets. Nevertheless, the main focus of PPprint was first on filaments, which basically came to the fact that 5, 6, 7 years ago, there was not a lot of granular printers on the market, FGF printers on the market. So there's was not that high interest in this because people just didn't have the machines to process the materials.
Mm-hmm.
Nevertheless, over the last years, it became a really growing field to have granulars, and that's what we also offer for specific printers. We actually do have a cooperation also with the printer manufacturer Wasp from Italy, which actually specifically modifies printers for PPprint to produce our pellets in highest quality on their machines. But also we work with several other granular fabricating machines, and it works really, really good. And yeah, basically it is the same idea of the filament that is behind it. The material is always developed, because this is an issue of PP, as you mentioned, to have the minimum possible shrinkage in the part, because this makes it basically, or made it years ago, unprintable, because let's say injection molding grades were just shrinking too much for extrusion-based processes. So this is the main thing, is to take a look at how can you reduce shrinkage, but you will, and that is something you have to say about polypropylene, it is impossible to have no shrinkage at all, because as a semi-crystalline material, there's always shrinkage, because this is later on the crystallization basically creates the durability of the part. So this is the one thing that we optimized it, but the other thing is the interlayer bonding. We wanted to create parts. We are still talking about layer by layer technology, yes, but we don't only want the layers to be solid, we want to have parts that can be used three-dimensional in the end. So where force can come from any side and the part lasts. And that is what we also used as a key reference point in developing the material, is that you can create parts that you can put force on in all different directions, in all three axes, without having a part that breaks maybe in the layers.
Right, right. And so that's coming off directly off of the printer with almost no post-processing whatsoever. We have some really nice interlayer bonding that I've noticed as well. I guess getting into maybe just any post-processing, would you suggest that people do some type of post-processing to these prints?
Well, it is definitely always a question about the application. So definitely there is no post-processing required for the parts. And I would say 95% of our customers also don't use any post-processing. Nevertheless, there are different ways of post-processing polypropylene, but what you have to say every time is PP is not the easiest material, which is basically the reason why PPprint also exists, because it has some hurdles that you have to overcome to be successful.
Sure.
And the post-processing basically comes to effect. It is a very durable material. So whatever post-processing method you use, you also have to flatten the material somehow. And current existing processes for post-processing often don't really work. Nevertheless, we in-house developed a process also that is a chemical vapor process in the end, kind of. But there are also more and more coming, and we're really happy about this. Companies to the market that can post-process polypropylene parts quite good. To mention maybe the company Dimension, who has a process there. And there's also actually I have a part here on my table that is post-processed with granular, so on a mechanical base. So also this could be possible. It always depends on what kind of surface you want to create. Nevertheless, if you print the part, you can definitely always achieve very good surface qualities without any post-processing.
Right, right. Yeah, I know that we at Ascent Fab, we end up taking a torch to some of the parts in areas that we know are going to be areas of high failure. So the distal end of a prosthetic socket, some of the posterior trim lines, or anywhere that's going to see high forces, we'll take a torch to it for a few seconds and kind of spot anneal those areas that I know that are prone to high failure. So that's, one thing that we do for post-processing that I found definitely makes a difference. So annealing could be a possibility, right? Vapor smoothing is definitely something I've gotten a few more questions about recently about, vapor smoothing FDM parts. In your opinion, is it worth it? Are there ways to do it cheaply enough that, still makes sense for an FDM printed part?
So that is definitely the thing. So the question is, what kind of setup are you currently having to produce your FDM parts? And you always have to think about, if your post-processing machine will be 10 times the cost maybe of your printer, then you kind of have to ask if this is the right process to go for. So this is definitely the case. We are having a process in-house at PPprint that we're also trying to develop further to make it available for customers. Nevertheless, we offer this service here in Germany. Doesn't make sense for maybe your audience in the US to send their parts to us to Germany and send them back.
Right.
But nevertheless, there are processes, and it's developing more and more to go into this direction. But just to mention, as you already know, Joe, is that as we have a skin certification for our P filament, it is often also not so necessary already, because you already have parts that are suitable for a skin contact. But you also have often to look at the roughness. But it's not only the material you have to look at there, it's also what layer height are you printing, basically what quality printer you're printing the device with. I think it's definitely a meaningful thing to post-process parts, FDM parts, yes, but only in specific applications where you really need the highest surface finishes, and you're also willing maybe to go the extra mile also financially on this.
Right. Yeah, definitely. Using a $60,000 vapor smoothing machine doesn't exactly equate to being able to 3D print your Polypro with a $300, artillery Sidewinder printer or something like that. But definitely an interesting pathway that, could help with some adoption, I think, in some fields. In our field, people look at the layer lines and just don't see it as kind of a finished part, right? So I understand that side of things from some people, but at the same time, having to put all these different features into a low cost part are definitely outweighing the benefits of having something vapor smooth. But I also like the attribute of polypro that it is not hydroscopic, right? So it doesn't absorb moisture from the air.
Exactly. Yeah, I think that is a very important fact that we sometimes also forget, because we only print polypropylene mostly in our facilities, in our printer factory, is that, let's say, compared to other technical filaments, mention maybe nylons, PAs, there has to be a drying pre-process, and that is really different with polypropylene. You can just leave out your spools. We recommend to put it in a bag or something like this just for the dust. But in the end, you don't need any pre-processing. You just can take it out of the box, put it in your printer, print right away, put it out, leave it for 2 months, and then use it again. So this really makes it easy for people to use and also to store, which is, I think, a big fact. So this is something that really makes 3D printing easier, because I think what we're trying to minimize, and we also talked about the post-processing, is what we're trying is to reduce the process times and also the steps that are necessary in a process. And if you can reduce any pre-processing, well, that's a great thing to have, because it just saves time and money in the end.
Right. Yeah, definitely. And you did mention before a little bit about your surface that you have as well. You just came out with a permanently bonded surface, right?
Exactly. So maybe from the surface, just the idea about the surface, or just the necessity of the surface, it comes from the fact that PP doesn't stick to anything, basically, which makes it a great material.
To itself, really, right?
If it's a finished part, this is exactly what you want, is a material that doesn't stick to anything, but that's good for a lot of applications. But while printing, it's obvious that if your first layer doesn't adhere at all to your metal plate, your glass plate, whatever you have in your printer, and it's just flying around filament there, it doesn't help you. But what we developed there, or there's a lot of solutions that you can use. I don't want to say there's not solutions, but I would say the solutions that are currently there are maybe not so professional, maybe, or usable.
Not as streamlined, yeah.
Yeah. So what you could do is you could do tapes, or even hairspray, or whatever, glue sticks, and that is also can work quite good. I would say with bigger parts, it can also be quite critical. But there is a solution, but it's not the perfect solution, because you always have to do a pre-process of putting on, let's say, glue or PP tape, and then it also melts. So the first layer basically connects with this glue. So you kind of have to clean the part after, you have to clean your printer, you have to prepare it. And what we developed is our so-called P surface, which has a quite similar structure than the PP, and it enables that you can just print on it right away without any pre-process, just like a build plate you put in your printer. You can print on it, it sticks very good while printing, very, very good, and then you can print right away. And yeah, in the end, you have parts very sticking good. They actually stick so good that we have to do one more thing at the end of the print. We have to heat up the printer.
Right.
A little bit. So the base plate, only the base plate. It's also not required to have any chamber heating for our polypropylenes. But you need to heat up the base plate to be able to remove the part very easy, because it sticks very good if it's not heated up.
Right.
So this is the surface, the idea behind it, and what we now develop more over the years. We started, it has kind of a rubber kind of structure, I would say, to describe it to the audience a little bit better. And we sell this in every size you want to, from lot size 1. But for coming more into this professional side of 3D printing, it is just necessary to have a fixed base plate that you could put in and out. And this is what we do. and also together with several printer manufacturers, to mention Race, there was also Prusa printers, so a wide range of printers were collaborating there to create base plates that you can put in the printers right away. You have a solid plate, you can print on it right away, and it makes it. So the goal of PPprint in general is to make plug-and-play solutions. We want that our customers have great success very fast. And this was not the case with polypropylene for years, because it was hard to print. You always had to have a bad solution. Support materials also an issue. And now we're getting more and more there to provide a complete set of hardware for your specific printer. And then next to the hardware set, we also are going more and more to develop with printer manufacturers specific print profiles for the slicers, so that you are having a great start, that you can produce great parts from the first part on, basically.
Right, right. And so it's not just the polypropylene that you've developed, but the support material as well, right? So yeah, can you take us through a little bit about, why that support is very necessary for some prints, and kind of how to use that material?
Yeah, sure. Like every FDM print, I would say, maybe just focus on FDM. We also offer it in granulars, or in pellets. But coming from the FDM side, if you want to produce complex parts with openings, overhangs, for you also the medical technology parts, for example, an orthotic device, you often have overhangs that are not possible to print without any support in it. So it's just necessary. The same issue occurs with the surface, with the support material. You need something that sticks very good to the part, but at the end you have to be also able to release it. And we're very happy that we also currently have the only support material worldwide that was developed for polypropylene, because then I would say the normal support materials they use, for example, PVA, are not suitable for PP because they just don't stick. And with our support material, it's actually the same idea. You print it. It's a breakaway support material. Maybe I can also say a little bit about this after, but
Sure.
you print it. It sticks very good. And after the print, you heat up the part to 100, a little bit over 100 degrees Celsius. You can do this in an oven. You can do this in boiling water, whatever you basically want to. And then you can release the support material very easy, because the connection between the support material and the PP decreases, and you can just remove it like chewing gum kind of structure. And also this support material, what I want to mention, is 100% recyclable. As you know, we also do this with you. We offer customers, especially in Europe at the moment, the opportunity to send back these support materials to us and get discount on the next order, because it is 100% recyclable. And as we are the producers, we think that we are the best point of recycling. And what we now actually offer also is, and we call it the R support, RP support 279, which is a completely 100% recycled support material, made of our own support materials, just to create a circular economy. And yeah, so, but also there you have to think about, that is actually what we do, and that's also what we were in discussion with, is we're doing this in Germany at the moment, the recycling process. And so we have to think about when does it make sense to ship out the filaments back from other countries.
Right.
So for example, if we are on the other side of the world and we're having 500 grams of support, is it really a greener process? Does it really have a better carbon footprint, or however you would measure sustainability there? Is it really more sustainable to send it back in these amounts? And it's not. So we're currently developing processes to build up hubs also worldwide that collect for us, just to create something that is meaningful there. To recycle support materials.
Sure. Yeah, I mean, having that availability to be able to recycle both of these materials, right? The support material and the polypro, are definitely some advantages to using them. Where there's the company out in Vermont, what is it, the Filabot, that has the a pretty entry point recycling machine for specifically FDM filament. Is that kind of the go-to process? Are there other companies that you know of that are doing that kind of recycling in the US or some other countries where that would be available?
Yeah. So what we are currently doing, we are collecting the support material. You also have to say that because of our printer factory in Germany, where we only print polypropylene, we also have a lot of own support material that we use. So we already have a big base of support materials to recycle. So this is the foundation of it. So of course, we're using our machines. In the end, the support material has to be cleaned in a way. So of course, it should be well, as much support material as possible in there and no other materials. So this is something to take a look on. We are using measurement technologies that maybe to see what materials we're talking about and to find out how pure the recycled or the material to be recycled is.
Sure.
But there are possibilities definitely to recycle, and there's also coming more and more low-cost recycling possibilities to the market, I think, or affordable ones where you just create new granulars out of support materials, for example, and then reproduce them to filaments. So this is definitely, I think, the future also of especially support materials, but also of other materials to use failed prints, maybe also in the O&P sector. Materials that came back. So for example, orthotic devices that were not only permanently used,
Sure.
that maybe
Yeah,
come
the
back.
patient's done with it. Yeah.
Yep.
And if we could, somehow sterilize that, again, maybe heat it up to 100 degrees C in order to, kind of sterilize that. And then we could maybe recycle it from there.
Yeah, so definitely SPP is sterilizable, and also maybe an interesting thing is, let's say, to grab it a little bit more, it's dishwasher safe. But obviously you can
Sure.
also clean other processes. So this is interesting for specific applications, but the possibility to clean it is very good. Nevertheless, you also have to think about certifications. So our material is certified for skin contact, yes, and it also has an FDA approval. So it's food safe basically in the end. And but you always have to think about recyclability. How much pure material do you have? How pure is your process? So we are currently figuring out, actually, with also a research project here in Germany with printer manufacturers together and also O&P providers together, to think about how we can do this in the field of medical technology to recycle materials in a way that it makes sense. We have a bunch of results there, and there's a lot possible, but you also have to think always about okay, you can create a very, very good recycling process where you can use the materials again, definitely possible, also for medical technology applications. But there's also the way of recycling materials, maybe in a process that is not so expensive in the end, where or also it's not only about the production process, it's also about the collecting process. So how pure can you collect materials in your facilities? This can also be an issue. But there's also the possibility of a circular economy coming in the direction of a kind of a downgrading cycle. If you use the material in medical technology, it doesn't necessarily mean, and this is the great thing about 3D printing as a cross-industry production technology, there's also the possibility to use it for applications where, for example, an FDA approval is just not necessary, because you're using clips in automotive industry or prototypes for tooling or tools, molds, whatever. So there's a lot of interesting ideas also to see what is the best process for my company to go for to recycle materials. But PP offers all the possibilities to create great materials after, for 3D printing, but also for other applications, of course.
Right. So is the polypropylene also food safe then as well?
Yes.
Could it be, and I just don't know. I haven't read the labels of too many, food containers or bottles these days. I've seen, high density and low density polyethylene, but not necessarily polypropylene into bottles. But would that be something interesting that could be applied here?
Definitely. PP is everywhere in the packaging and food industry. So probably you and everybody who's listening this had polypropylene in his hand today without noticing. So from the cap of the water bottle to other packagings, PP is used a lot in different applications in this kind, because it's a great material. Also in the industry of food production, PP is a very huge used material. So everything that is in the production of food in contact with the food, PP is used a lot. So there are several different great applications for polypropylene in general, also in this field of this world of packaging and food. And also interesting, it is definitely also for toys for kids, which is an interesting thing, because you don't have to worry about kids, for example, children taking parts in their mouth. You don't have to. There's no harm created by this, and it's also a very important fact. And this is why PP is also huge in these markets.
Interesting. Do you have any customers that are in those specific industries, in the food industry or in the toy industry?
Yeah, definitely we do.
Yeah.
We have several customers that are working there. We have a bunch of customers that are working, quite a big customer from Denmark, for example, that works, let's say, in the production of parts for very big gastronomies, let's say, franchise companies to produce parts for them.
Sure.
And they use a lot of polypropylene there. One application, for example, was a brush to clean fruit, actually. So fruit brushes where actually the parts were 3D printed for prototyping, but also for end applications. And then I think the English word is brittles were added to the holder, basically, and clean up vegetables. So this is, for example, exactly the part here. Only food safe materials are of interest. It's very, very limited there when it comes to materials. So this is one big customer that we're working with, but we also have several other customers from this industry also coming from the packaging of food, which is an interesting thing. I think you also have to mention there definitely that not polypropylene is the great material for this, but you always have to see the application if 3D printing is the right thing for it. And when it comes to packagings of food, it is definitely not a thing where customization is the key target. So it's like high scale, a lot amount of products that are produced there. So you should definitely think about if the production process 3D printing is there, if you produce hundreds of thousands of the same parts, the right technology. Nevertheless, we do a lot of interesting projects there, from prototypes also to end products that fit very good with polypropylene.
Yeah, maybe once we start using our black belt, conveyor belt printer, maybe that's where we start to get into the high volume production status for those kind of industries, for the really high volume number of parts that they print. And I looked at the bottle that held my cold brew coffee the other day, and I thought to myself, oh well, we could probably print that with polypro. Make something that would be maybe even reusable, sterilizable and reusable at some point by some local companies, maybe in some smaller numbers like that, and into the hundreds and thousands maybe, and not so much 10,000s of millions or something like that. But I think 3D printing is definitely coming along in the production status that way. I wanted to give you just a couple minutes here too to introduce your new polypro material here that's infused with chopped carbon fiber as well, right?
Yeah, sure. Yeah, we can definitely talk about this. It's one of our new innovations. So basically, as you already said, we are now offering also carbon fiber reinforced PP filament. Also, of course, as always, for the 1.75 as well as the 2.85 diameter, basically as the idea just to make it accessible to everybody. And it basically enables, which is quite obvious, using carbon fibers, it enables to produce more mechanical stable parts. like even more, I would say. I think that our normal polypropylene can withstand a lot, but sometimes you need a little bit more stiffer parts, or you have specific stuff. And yeah, that is basically what we're now offering. Also, we're very proud with a lot of research behind this, to develop a good material where we also have a great interlayer bonding, where we also basically create a product that is high quality. So we did a lot of research on there. How can we develop a material that is great? And it's very interesting, and also offers, again, a new range of new applications, also for, we call it hybrid parts. So the idea of printing with multi-nozzle printers and using our, let's say, normal polypropylene P filament, a 7-to-1, combined on another nozzle, that maybe some parts of the product are reinforced. And
yeah, that could be interesting for sure.
So the idea is basically to develop a material portfolio even further, where our materials stick perfectly to each other. So every different filament sticks perfectly to each other. We have great interlayer bondings, and then we can create parts that go beyond what you can currently do with 3D printing, because you're not only producing one material with its properties, you can use properties of different materials. And yeah, the idea is also to develop this even further and to offer, where we see the future is also in multi-nozzle printing, not only because of the speed, also because of the combination of, in our case, PP materials, to create parts that are perfectly suited for the application that they belong to.
Right. Yeah, I know it'll be interesting to start printing with the carbon fiber PP to see the differences in surface finish and strength as well. I could continue on, talking with you here, Sebastian, for a while. We've got our time up for today, but thanks for taking us through kind of an introduction to PPprint. If you are in the US and would like to try out some of their materials, we offer a free sample test kit through Ascent Fabrication. We'll send that out to you. Feel free to reach out through our website, ascentfab.com, or by email, joe@ascentfab.com. And I can definitely send you out a test kit of their materials. We will have some of this new carbon fiber poly pro in the coming weeks for those customers that are interested in testing that out as well. And we have a very large shipment from them just recently. So we have all of their colors and sizes in stock with some of their newly permanently bonded surface plates. So definitely some interesting things to try out here. And yeah, thanks again, Sebastian, for the time today. I appreciate it.
Thank you very much for having me, Joe. It was a pleasure.
Well, happy Fabrication Friday, everyone. Thank you for joining us today, and happy printing, and have a great weekend. Thanks.
Thank you.